Eureka, Science Wizards! This is Science 7, Quarter 1 under the Matatag curriculum. Science Universe, Party Particles in Motion. Content, the particle model and changes of state. Learning standard, learners learn that the particle model explains the properties of solids, liquids, and gases and the processes involved in changes of state. Learning competency, the learners describe the particle model of matter as all matter is made up of tiny particles with its pure substance having its own kind of particles. Learning objectives, at the end of 45-minute session, 80% of the learners are able to identify the basic principles of the particle model of matter, including the idea that matter is made up of tiny particles. Number 2, explain the particle model of matter as all matter is made up of tiny particles with its pure substance having its own kind of particles. And lastly, illustrate the particle model of matter as all matter is made up of tiny particles with its pure substance having its own kind of particles through conducting an activity of particle model. Now let's have an activity called Jumbled Letter Word. Arrange the letters to form the correct words related to our topic. Activity time. Guess the word. Create a word from this picture that is related to our topic for today. Matter. Particle. Liquid. Solid. Atom. Let's start. Particle model demonstration. Objective. Describe the particle model of matter. Materials. Transparent paper cups, thermocol bowls, and glue. Procedure. Students create models of particles using thermocol bowls, and each color represents a different type of particle. They arrange the particles to show how they are packed in solids, loosely arranged in liquids, and spread out in gases. Activity. Students draw diagrams of their models and explain the arrangement of particles in each state of matter. There is a link provided on YouTube where the student can watch, so they will be guided on how are they going to perform their activity accordingly. Now let us move on to the three different states of matter: the solid, liquid, and gas. Solid is rigid with fixed shape and fixed volume, and it cannot be squashed. Liquid is not rigid, with no fixed shape, but with fixed volume. And it also cannot be squashed. Gas, on the other hand, is not rigid, with no fixed shape and no fixed volume. Therefore, gas can be squashed. There are three main states of matter: the solid, liquid, and gas. Examples of solids include a table, a pencil, and ice. The atoms in a solid are packed tightly together, often in a particular order and pattern, and slowly vibrate. Atoms in a liquid are packed less tightly together and flow around each other. Atoms in a gas are often very spread out and speed around each other. All matter has three characteristics: mass, volume, and density. Mass tells us how many atoms are in an object, how much matter is there. Volume tells us how big the object is, how much space does it take up. And density describes how packed the atoms in the objects are. All matter is made up of tiny particles, with its pure substance having its own kind of particles. Refers to a fundamental concept in chemistry and physics known as the atomic theory. Tiny particles. All matter is composed of extremely small particles called atoms. These atoms are the building blocks of everything around us. Pure substances. A pure substance is made up of only one type of particle. There are two main types of pure substances. Elements. These are substances that consist of only one type of atom. For example, gold with chemical element Au is made entirely of gold atoms. Compounds. These are substances that consist of two or more types of atoms, chemically bonded together. For example, water with chemical element H2O is made of hydrogen and oxygen atoms bonded together. An atom is the smallest unit of ordinary matter that forms a chemical element. Atoms are made of fundamental particles called protons, neutrons, and electrons. The structure of atom. Protons and neutrons clump together to form a central nucleus. The electrons move in a cloud-like region around the nucleus, and most atoms are stable. Now let us discover the atomic model and theory timeline. As scientists have learned more and more about atoms, the atomic model has changed. First is Democritus. He claimed that matter was made of small, hard particles that he called atoms. He proposed that matter could not be divided into smaller pieces forever. Next is John Dalton. Dalton viewed atoms as tiny solid balls. He created the very first atomic theory. Next is J.J. Thomson. His atomic model was known as the Raisin-Bond model. He showed that the atom was made of even smaller things. Next is Ernest Rutherford. He showed that atoms have positive particles in the center and are mostly empty space. He discovered protons and the nucleus. Next is Neil Bohr. He proposed that electrons move around the nucleus in specific layers or shells. He improved on Rutherford's model. Next to Neil Bohr is James Chadwick. Working with Rutherford, he discovered particles with no charge. These particles were called as neutrons. So he discovered neutrons. In the modern days, the new atomic model has electrons moving around the nucleus in a cloud. Work done since 1920 has changed the model. Now let's elaborate, bringing Atom's secret to life. Write down the model and name of the scientist, its proposed model, along with the year it was proposed. There's a table presented with the model, proponent, and year. Let us test yourself. For the states of matter, so label each picture as solid, liquid, or gas. Now let's evaluate. So far, you learned that matter is anything that has mass and volume, and you have a better picture or view of how the particles are arranged in the three states of matter: solid, liquid, and gas. Matter is made up of tiny particles, and particles of matter are moving all the time. You have also learned about pure substances and its types, elements, and compounds. Lastly, the atomic theory and different scientists' contributions to our understanding of the structure of atom. So, assessment. Now let's extend. Explain how the changes of states occurs and cite examples. And illustrate the processes in the changes of state of matter. So, thank you so much for watching and listening.